Okay folks, today we're talking about mass and charge of particles. As we are aware, an atom contains subatomic particles, protons, neutrons and electrons. Now protons are positive, okay, neutrons no charge. P for proton, P for positive, that's how I remember it. Electrons hence have to be negative. Now the mass, M, we use 1 for protons and 1 for neutrons. That's not the actual mass. A lot of students get confused with this. That's a unit, an arbitrary unit we choose to use for ease. It's easier to write down 1. It's comparative, it's relative, okay? So it's 1 compared to electrons, which are 2000 times smaller. Them numbers are written down there. If you look at 1 over 1840 or 1 over 2000, depends on the exam board, but it shows that the electron is a lot smaller. Okay, that's the key thing. Now let's look at this table. So just a reminder, the charge is +1 for proton, mass is 1. Again, the mass itself and the charge, they don't have any units because they are relative. Okay, the actual masses, let's have a look at this. Look like this. You have an electron, its actual charge is there. Look how small that is, and it's measured in coulombs. And the actual mass in grams of an electron is there. Okay, if you're wondering what AMU is, it's atomic mass units. That's what we use. So the protons, as you can see, as I was saying, 1.67 times 10 to the minus 24 grams. That is so small, hence we use the numbers 1 for the mass of a proton, 1 for the mass of a neutron. Okay, this is to show you that the numbers we actually use are not the actual units. Okay, they're not the actual real mass and have no units, as I've said. That's the key difference, and we use 1 1, and the electron is far smaller. Never put a 0 there, because if it's 0 it won't exist, right? We always put a tiny number. I mean, look at the actual 0.005 AMUs, but that's why we use the 1 over 2000. Okay guys, I hope that helps.